If you think about it, mathematics is the same as weeb culture. Well, instead of simping for two-dimensional animate cities, they sim for extravagant curves and Lagrange charm.
Coming down of it. Coming down of a high. Fill you with my third eye. I swear I don't even know you. I'm with Billy like I'm Rodo. Coming down of a high. Fill you with my third eye. I swear I don't even know you. I'm with Billy like I'm Rodo.
What's up, guys? Welcome back to the Thunderdome. In today's episode of Whatever I Learned This Week, we are going to be talking about a bunch of unnecessary things that I've learned, and hopefully you're doing the same thing at home. So, first things first. When it comes to mathematics, I am in love. I have never loved anything more in my entire life, and yet here I am simping for numbers and curves and vivacious, sexy ass equations. So this week, I was reminded of the fact that a lot of my work is very serious and requires a crap ton of mental processing in order for me to understand and inherently apply all of the things that I learned. So I think that's why math is regarded as such a really, really hard subject, because it takes a lot of work. It takes an extended amount of work just to understand it, and a bit more just to apply it. And I think that's why people quit and think, no, I can never do mathematics. And I mean, I understand that I am very blessed to have access to the resources that I do, but practicing is for free. So to all of the people out there that are struggling with mathematics, I suggest that you take some time, maybe 2-3 hours and expend trying to understand what Lagrange is talking about when he was talking about interpolating polynomials, because he really did something there. It's the curves for me. Next, learning. So, Docker. This week I learned about Docker. Now, what is Docker? Well, for starters, I know all of the software developers in the community are absolutely going crazy at the fact that I started learning Docker, because it is such a good software. To put it simply, Docker is a piece of software that allows for a developer who has developed the application to pack every single thing that he's developed into one single container. Yes, the Docker people had fun when they created it, and they were like, we are gonna create an application that contains every application dependencies, and we're gonna call it containers. Yes, they use containers in order to pack all of the information, all of the data, the databases, the dependencies into one tightly packed image that you can install onto virtually any software that supports Docker. Docker is so unbelievable because it abstracts everything from itself. It's like a sort of application of virtualization, but in the coolest possible way. Instead of using things like the hypervisor to virtualize the container, it uses things called namespaces, which are specific Linux based programs that I'm not going to explain. I'm just going to link a video in the description so that you can learn the nitty-gritty of Docker if you want to. It's just that I just wanted to share how cool Docker is, because essentially it is one of the best containerizing softwares on the market, and it is very valuable for a team of developers to understand how to use it and how to use it well. I'm a bit busy with school, so I didn't have the time to finish the book that I was reading, but it's coming along nicely. So next, learning. I also learned about test-driven development. Now, when you're doing a degree at a school, they don't necessarily teach you about these cool ideologies. They'd be like, learn this, learn that, ask you questions, done, and then they're done. And you don't get to learn what test-driven development is. And I just learned it. I read a bunch of articles on Medium and on the internet about test-driven development, and it is the coolest ideology in software development I have ever had the honor to learn. So test-driven development is a way for a software developer to test their software as they develop it. Now, the cool thing about test-driven development is that you start with the tests, you create the tests, they fail, you create the software, and then it passes. And then if you make new implementation, like if you, optimize your code, then it'll have to I forget these words. It'll have to comply with the test in order for it to be allowed to be shipped. It has seen an increase of so many percentages in the development of applications since then. And with pairing with things like Docker, holy cow, development has never been faster than it is in today's time. And I'm pretty sure in the near future that development will be faster due to some innovation that some genius out there is coming up with as we speak. So Docker, test-driven development are really cool things that I learned this week. I don't delve into these topics because this is not a video about Docker or test-driven development. It's what I learned and what I found cool about these things and what I feel is worthy of sharing at this point in time. So as we move, next meme. See, now I'm acting like PewDiePie. So a while back, I was reading this book by Simon Singh called The Code Book, I think, and like it had the history of encryption and development of encryption and the battle between encryption and the breaking of encryption, right? And it had descriptions of the type of encryption that we use today. The type of encryption that we use today is what we call I don't know what it's called as a collection. It's just the encryption, but then it uses methods that were developed in like the 1970s by a group of people whose names I forgot. But a type of encryption that I'm talking about is what we call RSA. Now, RSA encryption is a type of encryption that uses, yes, you guessed it, mathematics in order to encrypt data. So think about it this way, right? People have always been able to encrypt things. Like simple encryption would be something like the Caesar cipher, where you have like a sentence, right? And then you shift the alphabet like one space to the left or one space to the right. It doesn't matter, where A is now in the position of B, and the way the position of A is, it's Z. That's you shifting to the right, and then it's where the position A is in the position of Z, and B is in the position of A. So B becomes the first letter and stuff like that. And then you use that shift to replace the word. I will show you a description of it here now. So yeah. Now, with that in mind, that is a simple Caesar cipher. And in order to decrypt it, you just shift it back and then just replace the letters again. Cool. Now, with today's advanced encryption, people were able to come up with a mathematical function that takes a bunch of data and then spews out encrypted data, right? So it's like your input is the thing that you want to encrypt, and the output is the cipher, right? So the function that does that is what is how do I describe this? Like, I can vividly see it in my head, but it is a bit hard to describe because the function looks like this. It is what we call a modulo. How this works is that you take a number, right, and then you the percentage sign is like a division, but instead of the number that it divides into, you get the remainder of the number. Now, this is a one-way function. I'm not going to prove it to you. You just have to intuitively understand. It is very impossible in order. Holy crap. It is impossible to get back because of various reasons. I do remember these reasons, but then I am far too lazy to explain these to you. So just trust me, okay? Just trust me. I know what I'm talking about. So, these functions are one-way functions that are able to encrypt data one way, and reversing that data would be very difficult, which is the encryption that we use today. This is just a terrible explanation of RSA encryption and like encryption of today. I should actually do more research and explain things better, but we are getting better at things, so give me a break. Next thing. There's no next thing that I learned. All that's left is to thank you for watching this video. Thank you for being tortured for 12 minutes while I speak about the beautiful things that I learned, because the chaos in my head needs to be ordered somehow, and this is the only place where I can express all of the nonsense that I have in my head without people getting confused. Well, people are still confused, but instead of them looking at me with a confused face, it's like comments and people are just confused. So I enjoy that better than I enjoy watching people be confused. In any case, it just dawned on me that it might be my fault that people are confused because I don't explain things well enough, even though they kind of make sense in my head, but then I should make sure that they make sense in other people's head, which would require me to put an extended amount of effort in trying to understand these things in the way that other people understand things. But that would require me to do some research on how people understand things and what they've experienced in their life, which is a whole other issue that I don't even want to get to, but it can't be helped. So to end off this rant, I would like to thank you for watching my video. Please subscribe, tell your friends, your family's pet goldfish, that one uncle that doesn't come to the parties but has all of the money in the world. Please tell him to subscribe, because there will be more videos that make absolutely no sense. And remember, we're still learning.